everyone, I hope all of you are doing great, and today I am here with the fourth video of the video series on squares and square roots class 8 maths. And today we are going to focus on square roots and how do we find square roots using different methods. I am Roshni from Learner Hub, the free learning platform where you get to study everything about maths and science absolutely for free at learnerhub.com, and we upload new video every day. So please stay tuned and subscribe to the channel to get the latest updates. So are you all ready to learn with me? Let's get started. So now we are going to talk about another new concept, that is square roots. So this might be a new term for you right now. You might be thinking that what could be root in mathematics, because we have learned about roots of the plants. But how are roots of the plants related to squares? Well, here we are not going to talk about roots of the plants, but we are going to talk about a function which is an inverse function of squares. Okay. So let me take this example. Let's say that there is a park in your locality which is in the shape of a square, because we have been learning about squares since quite some time. So you have a park. The area of the park is 1600 meters square. That means the total region enclosed by the square is 1600 meters square. So you know the area this time. So now your friend asks you what is the length of each side of the park, because you do not know how long is each side of the park. So that's not known to you. So how will you find out the length of each side of the park? So all we know that area of a square is equal to side square. That is, whatever is the length of the side, square of that gives area. So 1600 is the area which is known to us. But what is the side? How will we find out the value of side? So this becomes difficult because you really do not know what to do. You know that square of the side is equal to 1600. But how much exactly is the value of the side? How will you find that? So that is where we make use of square root. So here we are going to introduce you to inverse functions. Now this is not a new thing. You know this, you have learned about this, but it is just that we are making it more more official now. Let's say that this is you. Your father gave you 5 chocolates. Okay. So how many total chocolates do you have with you? You have 5 chocolates. Now your mother gave you 3 more chocolates. So how many chocolates do you have with you now? You already had 5 plus your mother gave you 3. So how many chocolates do you have in total? So you have 8 chocolates in all, right? So what is the operation that you did in order to find out the total number of chocolates? You did addition. You added the number of chocolates given by your father with the number of chocolates given by your mother, and that's how you counted the total number of chocolates that you have. So looking at this, what do we see? That if we want to get, so let's say that there are 2 numbers. Now let's focus only on the numbers. So if you want to get 8 from 5, so if I give you 5 and I tell you that you have to make these 5 toffees 8 toffees. How will you make the 5 toffees 8 toffees? By adding 3 more toffees. So when you want to get 8 from 5, you do addition, right? Now if I tell you that I give you 8 toffees and you have to make 5 toffees, that means I am giving you more number of toffees and you have to make it 5. So what do you need to do? To make 8 chocolates to 5 chocolates, you need to eat 3 of them, right? So basically what you are doing, you have to subtract 3 toffees from 8. Only then you would get 5 toffees. Correct? So what do you see? You see that addition and subtraction, they are inverse function. So if you want to get 8 from 5, you add 3. But if you want to get 5 from 8, you subtract 3. So you deal with the same number. You are still dealing with the number 3. But instead of adding, you are subtracting it. So that is why we say that addition and subtraction are inverse functions. So I hope you understood the concept of inverse functions. Let us take one more example. Let's say that 8 multiplied by 5 gives you 40. So if I tell you that I give you 8 chocolates, right, and you have to make them 40 by multiplying. So how will you multiply? Let's say that you have one box of chocolate which has, one box has 8 chocolates, right? So how many boxes will you need such that the total number of chocolates is 40? So basically you want 40 from 8. So what will you do to get 40 from 8? You multiply by 5. Now if I tell you that I give you 40 and you have to make it 8. So what will you do? How will you get 8 from 40? So this time also you deal with the same number 5, but instead of multiplying, you divide. So 8 multiplied by 5 gives you 40, which means that 40 divided by 5 gives you 8. So with this, you get to know that multiplication and division are also inverse functions. Now on similar lines, let's talk about squares. Now when I tell you 2 square gives you 4. So that means if I want to get 4 from 2, what do? I square 2. So if I want to get 4 from 2 by squaring, then I square 2. Now if I tell you that I want to get 2 from 4, so I want 2 from 4. So what should I do to 4 such that I get 2? So this time you need a new operation, and that new operation is square root. So square root and squares are inverse functions. So basically when you say 2 square is equal to 4, that actually means that square root of 4 is equal to 2. So square root of any number is that number which when multiplied to itself gives you the other number. For example, if you say that square root of 100 is what? That means square root of 100 should be that number such that the number when multiplied to itself gives you 100. So what is that number? That number is 10, because if you multiply 10 with itself, that is 10 into 10, you get 100. So if I ask you what is the square root of 25, so you need one such number which when multiplied to itself gives you 25. So the answer would be 5, because 5 square is equal to 25. That is 5 multiplied to itself gives you 25. So this is square root. So I hope you understood what is square root. So square root is a new function for you. It is the inverse function of square. Okay, now why do we call this square root? That's because when you look at it very closely, okay, as I said, that roots are something which you could more easily relate to plants. The base, the parts which are present towards the base of the plant, they gives the strength to the plant, they support, they give mechanical support to the plant, right? So they are present in the lower part of the plant, or they are present in the base of the plant. So with that logic in mind, you can very easily see why these are named square roots. I mean, this is one way to, prove that analogy. Like here in this case, 2 to the power 2 is 2 square. So here, this 2 which is at the power, and the base 2 is, this 2 is called the base. For example, if you say 3 square, here 3 is the base. If you say 4 square, so 4 is the base. Right? So whenever you write a square, the number which is at the bottom is the base, and this 2 is nothing but the power. So in square root, you would have seen that the value that we get is the base. So we are actually getting the value of the base using square root. For example, root over 25. The value of root over 25 is 5. So if you look at the square function, it is 5 square is equal to 25. So with this square root operation, you are actually finding out the value of the base. So that is why this is called root. So square root, because this is it. We have the term square because it is inverse function of square. Root because it gives you the value of the base. That is why it is called square root. So now let's look at square roots of different numbers. So till now, while we were discussing about squares of numbers, this is something that we were always referring to, like the squares of the first few numbers. Right? Now let us look at the square roots of these squares, because as I said, square roots are inverse function of square. So if I say 1 square is equal to 1, that actually means that square root of 1 is equal to 1. So here, so I think the first example will not be a very good example to illustrate this. So let's move on to the next one. You see 2 square is equal to 4. So to get 4 from 2, we square 2. But to get 2 from 4, we find square root of 4. Similarly, to get 3 from 9, we square 3. But to get 3 from 9, we square root 9. So you see, they are just the inverse function. So if 4 square is 16, that means square root of 16 is equal to 4. And in a similar way, we can find out the square root of the first few perfect squares. Now, this next question that might strike your mind is, that means we can find square root only for perfect squares. Well, in a way, yes, when you say that the value of square root, if you say that the value of square root should be a whole number, in that case, yes. The square root value of perfect squares will only be whole numbers, like square root of 25 would be 5. But if I ask you to find out the square root of 24, you cannot get one whole number, because 24 is not a perfect square. There is no such number which when multiplied to itself gives 24. So you cannot get root over 24's value as one whole number, even if you try to find it out. So for root over 35, you will not be able to get a whole number. So yes, when we are talking about the basics of square root, we will right now deal with the perfect squares. So then now next question that comes to your mind is, how do we find square root of a number? That it seems to be a big challenge, that finding squares were pretty easier because we only had to multiply, even if we go by the actual multiplication method, but then we learned some tricks also to make that easier. But how do we find square root? Now we have a couple of options. So first let us talk about the simplest option, which is repeated subtraction. Though it is the simplest option, but it is not a very favorable or very suitable one. But still, we will learn about it. Now if you remember, while we were learning about squares of numbers, we saw that to find square numbers, we added odd numbers. So I think this list would help you to go back to the recap. So you see, for all the perfect squares 1, 4, 9, 16, 25, 36 and so on, to find their values, we just kept on adding odd numbers, right? And then we said that the sum of first n odd numbers is n square, and that n square is a perfect square. So that was one way of finding squares of numbers. Now we saw that square root is just the inverse function of squares. So this time also we will do something with the odd numbers, but we will not add. Instead of addition, we will subtract them. So that is why this method is repeated subtraction method. So let us take one example. Let's say we consider the number 25. So you have to find out the square root of 25. So what are we going to do? We are going to subtract odd numbers from 25. And how are we going to do that? So we will do it in steps. So in first step, we subtract the first odd number from 25. The first odd number is 1. So how much do we get? We get 24. In the second step, we further subtract from 24, like from the result that we obtained in step 1, from that we subtract the next odd number, which is 3. So 24 minus 3 is 21. In third step, we subtract from 21 the next odd number, which is 5. So this becomes 16. In fourth step, we subtract from 16 the next odd number, which is 7. So we get 9. Now you might be thinking that how long are we going to do this? So we will continue this process until and unless we get a 0 here. So in step number 5, we are going to subtract the next odd number from 9, and the next odd number is also 9. So the result is 0. So what happens is, doesn't matter whichever the number is for which you want to find out the square root. So if that is a perfect square, only then you will get a whole number for the square root, right? So you will be able to find out the square root only for the perfect squares, right? So if it is a perfect square, then as you keep subtracting an odd number from that number, you finally would get 0. Now what you have to do? Now you have to see in how many steps did you get this 0. In how many steps? 1, 2, 3, 4, 5. So you got this in 5 steps. So that means square root of 25 is 5. It is as simple as that. Okay. Now you might be thinking, when we were doing squares, we were adding consecutive odd numbers, right? For example, to get 25, we added the first 5 odd numbers. So here also we did the same thing basically. We subtracted the first 5 odd numbers. So since it is subtraction, so we try to do this in 5 separate steps so that it becomes easy for you to see that how many times you did that subtraction. So you see, just the inverse thing. So since square root is inverse of square, so to find squares, we added odd numbers. To get square root, we subtract odd numbers. Perfect. However, this method is not suitable for large numbers. For example, here we took 25, so that was fine. Now let's say that if I ask you to find out the square root of 121. So do you think that this is a very suitable method? Because in that case, the square root of 121 is actually 11. So you are actually going to have some 11 steps like this. So if I ask you to find out square root of 1600, so you will have some 40 steps. So this number is not at all suitable for large numbers. So we need some other method. Let's look at the second option that we have, and that is the prime factorization method. So I hope all of you remember what is prime factorization. If you are given a number, you can write that number in terms of product of its prime factors. That is factors of number which are also prime numbers. So if you have forgotten how to do prime factorization, you can refer the mathematics videos of class 6th. Okay. So for now, let's take an example. So let's say that you have to find out square root of 100. So we are taking a simpler example to understand it for now. So our first step would be to prime factorize 100. So how do we do prime factorization? By dividing it by the smallest possible prime number such that that prime number exactly divides this number 100. So in this case, that smallest prime number would be 2. So 2 into 50 is 100. Further again it would be 2. So 2 into 25 would be 50. Then it is not 2, not 3, because 3 doesn't divide 25 completely. Then it would be 5. So 5 into 5 is 25, and then 5 into 1. So therefore, you can say 100 can be written as 2 into 2 into 5 into 5. So 2 into 2 into 5 into 5. So how many times we have 2? So 2 multiplied to itself, that is 2 square. Similarly, 5 multiplied to itself is 5 square. So 2 square into 5 square is actually 2 into 5 whole square. So 2 into 5 is 10. So we see that 100 is equal to 10 square. So that means if I want to get 100 from 10, we square 10. So if we want to get 10 from 100, we will have to find its square root. So square root of 100 is equal to 10. So in this fashion, we can also find out square root. So looking at this method itself, you would have seen that it is a more organized method and a better method, of course, than the repeated subtraction method. So let us take one more example. So this time, let's take a bigger number. So let's say you have to find out square root of 7744. So let's prime factorize it. 7744. So it will get divided by 2. 2 into 3872 gives 7744. Then again 2 1s are 2, 2 9s are 18, 2 3s are 6, 2 6s are 12. Then again 2 9s are 18, 2 6s are 12, 2 8s are 16. Then again 2 into 4 is 8, 2 8s are 16, 2 4s are 8. Again 2 2s are 4, 2 4s are 8, 2 2s are 4. 2 1s are 2, 2 2s are 4, 2 1s are 2. And then this 121 is not divisible by 2, 3, 4, 5, 6, 7, 8, 9, 10, but it is divisible by 11. Now for such cases, you know what you can do is when you have 1 at the end, so it is very obvious that it is not divisible by 2, 4, 6 or 8. It is also not divisible by 10. So you are left with very few options, that is 3, 7 and 11. So you try only those numbers, right? So that you do not waste a lot of time. So therefore, looking at this, you can say that 7744 is 2 into 2 into 2 into 2 into 2 into 2. So you have 6 times 2 and 2 times 11. So now you make pairs of 2 so that it makes our job easier. So a pair of 2 is 2 square. Again, another pair of 2 is a 2 square again. One more pair of 2, 2 square, and then a pair of 11, which is 11 square. So this can be written as 2 into 2 into 2 into 11 whole square. So therefore, we can say root over 7744 will be equal to 2 into 2 into 2 into 11, which is equal to 88. So therefore, square root of 7744 is equal to 88. So you see, this is a more convenient method to find out square root of a number. Now, with the help of this prime factorization method, you can even find out whether a given number is a perfect square or not. So this is another way. Because what might happen is, you might sometimes come across numbers for which you are unable to find the square root. So let me give you an example. Let's say that you are given a number 220 and I asked you to find out the square root of 220. So as per process, you will do its prime factorization. So 2 ones are 2, 2 ones are 2, 0, and then 2 fives are 10, 2 fives are 10, 5 11s are 55. So 220 can be written as 2 into 2 into 5 into 11. Now when you look at this, you see that 2 exists in pairs, so you can write it as 2 square. But 5 doesn't exist in pair. Similarly, 11 doesn't exist in pair. So therefore, we are not able to write 220 as square of some number. Only when we are able to write it as square of some number, only that means that 220 is a perfect square. But in this case, we are unable to write 220 as a square of a single number. This shows that 220 is not a perfect square. Now, if 220 is not a perfect square, we will never be able to get the square root of 220. Like, you will not get a whole number for square root of 220. So now if I ask you that, is there any way that you can find out the nearest perfect square? So, okay, we got it that 220 is not a perfect square. So what do you think could be a perfect square somewhere near to 220? Now, to find out the perfect square, one option is you either divide 220 by 5 into 11, because if you divide 220 by 5 into 11, what will happen? This 5 and 11 will vanish, so you will be left with 2 to the power 2, which is 4, which is a perfect square. Another option is you multiply 220. So there are two options. Option 1 is divide 220 by 5 into 11. So if you divide 220 by 5 into 11, what will happen? This 5 into 11 will vanish and you will be left with 4, which is a perfect square. The second option is you multiply 220 by 5 into 11. In that case, what will happen? In that case, you will get 2 5, that is 5 square. You will get 2 11, that is 11 square. So in this case, so when you do this, the 220 number changes to 4. So 4 is a perfect square. And when you do this, then the number 220 changes to what number? It becomes 220 into 5 into 11. And this number becomes equal to 2 square into 5 square into 11 square, because this time you have multiplied it with 5 by 11. So this becomes 2 into 5 into 11 whole square. That is 110 whole square. So if you follow the second option, you get 110 whole square, which is a perfect square. If you follow the first option, you get 2 square, which is 4, which is a perfect square. So therefore, for non-perfect square, if you ever come across this situation where when you prime factorize a given number, you are not able to see that number as a square of a whole number, that means that number is not a perfect square. But if you still want to get a perfect square from that number, then you either need to multiply or divide that number with this extra part of the number, because In this case, this 220 is not a perfect square because of this extra part, 5 into 11. So this is the extra part which is not allowing it to be a perfect square. So you either divide this number by this extra part or you multiply this number by this extra part. In that case, this becomes the number gets converted into a perfect square number. Question number 1. For the number 2645, find the smallest whole number by which it should be divided so as to get a perfect square. Also find the square root of the square. Okay. First, let's try to see whether 2645 is a perfect square or not. So for that, what we would do its prime factorization. So when you do its prime factorization, the smallest prime number that divides it completely is 5. So 5 into 529 is 2645. Then the next smallest prime number would be 23. So 23 into 23 is 529 and then 23 into 1 is this. So this can be written as 2645 is equal to 5 into 23 into 23. So you see 5 does not exist in pairs, but 23 exists in pairs. So we can write it as 5 into 23 square. So now what do you see? Do you think that 2645 is a perfect square? No, it is not, because you cannot write it as square of a single number because 5 exists singly. So then what should we do? What can we do to get a perfect square from this? Because the question asks what is the smallest whole number by which it should be divided so as to get a perfect square. So what is that extra thing because of which it is not a perfect square? 5 is that extra thing. So if we divide it by 5, then 5 and 5 will get cancelled out. So this will become a perfect square. Therefore, it should be divided by 5. Now what happens if you divide it by 5? So the moment you divide it by 5, it becomes 23 square, right? So 23 square is equal to how much? This would be equal to 529. So therefore, root over 529 is equal to 23. So this 23 is the square root of the new square. The new square is 529. Question number 2. The students of class 8 of a school donated rupees 2401 in all for Prime Minister's National Relief Fund. Each student donated as many rupees as the number of students in the class. Find the number of students in the class. So we do not know the number of students in the class. We also do not know how much money each of them donated. But we know that the amount that each donated is equal to the total number of students in the class. So let us assume that total number of students in the class is equal to X. So if total number of students is X, then the donation per student is how much? So donation per student is also equal to X. So that is also rupees X. So what would be the total donation? So the total donation that gets collected will be equal to rupees X into X. X is each student's donation multiplied by the number of students who donated. But according to the question, the total donation is rupees 2401. So basically X into X is equal to 2401. So X into X would be X square is equal to 2401. So what would be the value of X? X will be equal to square root of 2401. So how do we find the square root? So for that we will do prime factorization. So it gets divided by 7. 7 into 343. Then again 7 into 49. Then again 7 into 7. So therefore 2401 can be written as 7 into 7 into 7 into 7. That is equal to 7 square into 7 square, which is equal to 7 into 7 square. So 2401 is equal to 49 square. Therefore, root over 2401 is equal to 49. So therefore, there are 49 students in the class. Question number 3. Find the smallest square number that is divisible by each of the numbers 4, 9 and 10. So a number that is divisible by each of these numbers, what would that number be? So that number will be a multiple of each of these numbers. So basically that number will be a common multiple of 4, 9 and 10. So you want the smallest number. So basically we need to calculate the least common multiple of 4, 9 and 10. So that is LCM of 4, 9 and 10. So how do we find LCM? Again, we have learned all of this. You want to revise, go back to the mathematics videos of class 6th. So this will get divided by 2. This is 5. Then again this is 2 ones are 2. This is 9. This is 5. Then 5 and then 9. So the LCM will be equal to 2 into 2 into 5 into 9. That is equal to 180. So 180 is the least common multiple. But the question is, the question asks us to find out the smallest square number that is divisible by all of these. So we know that this is the smallest number which is divisible by all of these. But is this a square number? So is 180 a square number? So is it a perfect square? So that is something we have to find out. So let us try to find its square root. Now you prime factorize it. So this is 2 into 90, 2 into 45, 3 into 15, 3 5s are 15. So therefore 180 can be written as 2 into 2 into 3 into 3 into 5. So this can be written as 2 square into 3 square into 5. So is this a perfect square? No, this is not a perfect square. So what should you do to get the nearest perfect square of this? So in order to get the nearest perfect square, let us multiply this by 5, because 5 is that extra part because of which this is not a square number. So now we have two conditions. We have to make it a perfect square, and we also need to make that number divisible by 4, 9 and 10. So therefore we multiply by 5. So what happens? This becomes 180 into 5, that is 2 square into 3 square into 5 square. So this actually becomes 2 into 3 into 5 whole square, that is 30 whole square, which is equal to 900. Therefore 900 is the smallest square number that is divisible by 4, 9 and 10. Question number 4. For the number 768, find the smallest whole number by which it should be multiplied so as to get a perfect square number. Okay, so let's first factorize 768. So 2 into 384, then 2 into 19 into 2. So this is 192, then again 2 9s are 18, 2 6s are 12, then 2 4s are 8, 2 8s are 16, 2 2s are 4, 2 4s are 8, 2 1s are 2, 2 2s are 4, 2 6s are 12, 2 3s are 6. So therefore 768 can be written as 2 into 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 2. So 8 times 2 into 3. So now you put the 2's in pairs. So this becomes 2 square into 2 square into 2 square into 2 square into 3. So this 3 is an extra part because of which 768 is not a square number. So what is that number by which it should be multiplied? So if we multiply it by 3, then what will happen? This 3 will also become 3 square. So therefore it would become a perfect square. Therefore it should be multiplied by 3. So when you multiply it by 3, it becomes 2 into 2 into 2 into 2 into 3 square. That is equal to 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 3s are 48. So 48 whole square is equal to, this side it will be 768 into 3, which is equal to 2304. So therefore we can say square root of 2304 is equal to 48.
I hope you found the video useful, and if you really understood the concept well, do write in the comment section that concept hua crystal clear. And I will see you all very soon with a new topic and a new video. Till then, take care. Bye-bye.